Hello students, we're just going to have a go at two of these questions in section or exercise 3.7 question 5. So we'll do question A because we need that for question D, and then we'll just do question D. So question B and question C, once you've done question A, are relatively straightforward, so we'll leave you those to do as an exercise. So let's get started. So consider the function f of x equals 3 log to the base e of 2x. And question A says determine an expression for the derivative of x. So have a go at that. Please stop the video, see how you go. You've done these before. And let's see if what you came up with is what I came up with. So first off, the 3 just stays, it's a coefficient, it just stays as part of the derivative. The inside function 2x, the derivative of that is 2, and derivative of log of something is 1 over something, so 1 over 2x. The 2 on the top and the 2 on the bottom cancel out, and that leaves that expression for the derivative. Okay, moving on from that, let's now start question D. Now this is effectively the same question as number 4, but there's a bit of a twist. They're not telling you what the gradient of the tangent is or the gradient of the curve is. They're saying the tangent is parallel to the line 2x take y equals 0. So we have to basically find the gradient of that line first, and that's the number that's the value that we'll use to find the equation of the tangent line. So again, you might want to have a go at this on your own. Otherwise, keep watching. Okay, so let's just write it in the form y equals mx plus c. So bring the y by itself, and that means y equals 2x, and that means the gradient is 2. And because the derivative, and that means the gradient of the other function, the tangent line, is 2, and that also means the gradient of the function is 2. This is the gradient of the function, and the gradient of the tangent line are equal. So now we know what the derivative, or the derivative of the function is. Okay, now we've also got the expression for f dash of x, so that must equal that, which is where that comes from. Multiply both sides by x, divide both sides by 2, and we get, that's the x coordinate for the point that we're looking for. So again, you may wish to stop now, see if you can finish it off on your own. Okay, so what I've done here is I've got this value for x. I can find the value for y, or f of x, by plugging 3/2 into this equation. Okay, so 3/2 multiplied by 2 is just 3. So there's the value for y. And of course, the equation of a straight line is y equals mx plus c. So that goes in place of y. The gradient is 2 from over here, so m equals 2. And the x coordinate is 3/2, and c is what we're trying to find. So the standard way of doing these questions is find the gradient, find x and y, sub it into that, solve for c. Okay, the 2's cross out. That leaves us with c equals, well, what I did here is I brought the 3 up top. So I get natural log of 3 to the power of 3, or natural log of 27. You could leave it like that if you wanted to. That would be fine. And so that is that, take away 3, because that's a 3 just there. And therefore, there's the equation, y equals mx plus c. And we are done with question 5a and 5d. Again, B and C are relatively straightforward, so I suggest if you think you need to practice at that, have a go at those as well on your own and check the answer in the textbook.